So this next section is basically a medley of factoring, various factoring methods. And here are the ones we have so far. Common factor, AB plus AD, AB plus AC, remove a common factor of A times B plus C. Then there's what I call unfoil, and they call foil a factor by grouping. AB plus AC plus DB plus DC. You factor A out of these, you factor D out of these, you factor B plus C out of both. You get A plus D times B plus C. There's a PQ method, there's the AC method. We reviewed those. I'm not describing right here. There's perfect squares. If you have square plus twice product plus square, that's the square of a sum. We have square minus twice product plus square, that's the square of a difference. Difference of squares is difference times sum. Difference of cubes is difference times square plus product plus square. Sum of cubes is sum times square minus product plus square. Don't confuse these with these. Here it's 2AB in the middle. Here it's plus or minus 2AB in the middle. Here it's AB in the middle. So very different. And in fact, this A squared plus AB plus B squared and this, neither of these factor in real numbers or indeed rational numbers. You'll have to involve the square root of -1 and the square root of 3. It gets messy. But there we go. All right, let's move on. Number 2. All right, so we'll just use this medley of factoring methods and see what we get. 8p cubed q7 plus 4p squared q cubed. 8 and 4 have a common factor of 4. That comes out. P3, P2, pull out the lower power, p squared. Q7, Q3, pull out the lower power, q cubed. 4p squared q cubed. When you divide this into each of these two terms, you get 2p q to the fourth plus 1. So this. Now here there's a common factor of 2, and they wrote it in reverse, which is annoying. So okay, we pull out a common factor of 2, and then 40y squared over 2 is 20y squared. 24y over 2 is 12y. 2 over 2 is 1. 2 times 20y squared plus 12y plus 1. All right, to factor this, we'll need the AC method. So we'll need P and Q, whose sum is the middle coefficient, 12, and whose product is A times C. That's 20 times 1 makes 20. Now, long story short, 10 and 2 work. Their sum is 12, their product's 20. So we'll write this 12y as 10y plus 2y. So 2, and don't forget the 2 to bring it along the whole way, times 20y squared plus 10y plus 2y plus 1. These two terms have a common factor of 10y, and dividing them into there, times 2y plus 1 is 2y plus 1 times 1. Now, pull out a common factor, 2y plus 1, leaves 10y plus 1, and we still have the 2. So it's this, 2 times 10y plus 1 times 2y plus 1. Do remember, if there's a factor being pulled along, please don't drop it in the last step. It's so frustrating. I see someone going, yeah, you got it. Oh, no. So bring it all along. Here is 8x to the fourth minus 8. Obviously, out comes a common factor of 8, leaving times x to the fourth minus 1. Now, fourth power is the square of a square, and 1 is 1 squared. So this is a difference of squares. So it'll be x squared minus 1 times x squared plus 1. This x squared minus 1 in turn factors into a difference times the sum. This will keep the same for now. So it's 8 times x minus 1 times x plus 1 times x squared plus 1. All right. Minus 20m to the third minus 100m squared minus 125m. Okay, there's a common factor of -5 out it comes. There's also a common factor of m out that comes, so minus 5m times. Divide each of these terms by minus 5m, we're left with 4m squared plus 20m plus 25. Now, okay, this one turns out to be a perfect square because this 4m squared is the square of 2m, this 25 is the square of 5, And let's see if this 20m is twice the product. 2 times 2m plus 5, you multiply it out. Yes, it's 20m. So this is square plus twice product plus square. And that's the square of the sum. So minus 5m, keep that along, times 2m plus 5 all squared. And that's that. Here is 2c squared minus 5cd minus 3d squared equals what? Now, this is an AC problem. We need to find P and Q, whose sum is the middle coefficient, negative 5, and whose product is 2 times negative 3, that's a negative 6. And negative 6 and 1 work. Their sum's negative 5, their product's negative 6. So write the minus 5CD as minus 6CD plus 1CD. And okay, the AC method then works in the usual way from that point. 2c squared minus 6cd as a common factor of 2c. Dividing these by 2c leaves c plus 3d. cd minus 3d squared has a common factor of d times, again, c minus 3d. So pull out a common factor of c minus 3d, and that times 2c plus d, and that factors it. Here's 6x squared minus 14x plus 8. Now, 6, 14, and 8 are all even, so let's pull out a factor of 2. And now, 3x squared minus 7x plus 4. That's what happens when you divide this by 2. So we need P and Q, whose sum is negative 7. And whose product is 3 times 4, which is 12. And negative 3 and negative 4 work. In previous section, I went through a whole table, searched through a whole table of factors of 12, but that's not necessary now. I'll assume that you will do that on your own. So, okay, negative 3 and negative 4. So, negative 7x is minus 3x minus 4x. So, 2 times 3x squared minus 3x minus 4x plus 4. Okay, here there's a common factor of 3x times, when you divide, x plus minus 1. Now here, okay, you could say a factor of 4, but really it saves a step if you pull out a negative 4, and then that's times x minus 1. Pull out an x minus 1, keep the 2, 3x minus 4, and here it is. 2 times 3x minus 4 times x minus 1. Four x squared plus 9y squared. Well, this is a square of 2x. This is a square of 3y, but we do not yet have a formula for a sum of squares. To do that, we'd have to have a square root of negative 1. We'll be discussing that by the end of the course. But until then, we'll say it does not factor, or equivalently, you can say it's prime. So either of these phrases will be an answer to this problem. Here's 16a to the fifth minus 54a to the second. Now 16 and 54 have a common factor of 2. A to the fifth and a to the second have a common factor of a squared. So remove a factor of 2a squared, and then this, after dividing, gets you 8a cubed minus 27. Now, okay, this 8a cubed is a cube of 2a. 27 is a cube of 3. So 2a squared times 2a all cubed minus 3 all cubed. Okay, difference of cubes is difference times square plus product plus square. And then after cleaning this up a bit, we get 2a squared, and remember to bring that factor along the whole time, times 2a minus 3 times 4a squared plus 6a plus 9, this. And here we have 49p squared plus 28p cubed plus 4q squared. Now, all right, I looked at the 49p squared and the 4q squared, and each of those are squares. 49p squared is the square of 7p. 4q squared is the square of 2q. Now, this middle term here, let's check if it equals twice a product. 2 times 7p times 2q does indeed multiply out to 28p cubed. So good. Square plus twice product plus square. And so therefore, it's the square of a sum, square of 7p plus 2q, this. Now here, x to the fourth minus 13x squared plus 36. Now, all right, this is a square of a square. This considers x squared. This is a PQ problem. We need P and Q, who sum to negative 13, and whose product is 36. And negative 4 and negative 9 work fine. So x squared minus 4 times x squared minus 9. Now this is a difference of squares, and this is a difference of squares, because 4 is 2 squared, 9 is 3 squared. So this factors into x minus 2 times x plus 2. This factors into x minus 3 times x plus 3. And all those 4 factors multiply out and factorize this. Okay.
Can you go back to 71?
Let's take a look. 71. This one?
Yes.
Okay. Okay, when you're doing something like this, it's sort of on spec. I think maybe this is a square of a sum. And this is a square. That's a square. That's easy enough. And then if the product of these, twice the product of these two things is the middle term, then you're good. Okay. And in fact, 7p times q, 2q times 2 does multiply out to 28pq. So this expression is square plus twice product plus square, and square plus twice product plus square is a square of a sum. Okay, and yeah, here, like I say, when this sort of thing, I was going to say, let's see, it looks squarish. Let's see, does it work? And so generally, when this sort of thing, I first see if that's a square, and if the product twice the product is the middle thing, then we're done.
How did you get the end answer?
What's that?
How did you get the end result answer to where the middle portions aren't in there?
Well, the middle portions aren't what?
The middle portions aren't in there. So how did you get the end product answer with just a 7p and 2q?
From here to here, square. Okay, I think I had that earlier. Just a second. Let's look at the beginning. The rule is that a square plus twice a product plus a square is a square of a sum. That's the rule. You see. And I did an example like this one here. It's all the other ones. It's a process, but this one it's more like you have to. It's pattern recognition. If you recognize the pattern square plus product plus twice product plus square, then you're there. You see. I mean, for example, 4m squared plus 20m plus 25. Well, gee, this is a square of 2m. This is a square of 25. And then say, that middle term, 20m, let's see, is it twice the product? 2 times 2m plus 5 times 5? Yes, it's 20m. So there it is. And then square plus twice product plus square is square of a sum. So, I mean, all these other ones, AC method, PQ method, it's a whole process. This one, it's more like if you can recognize the pattern, then you're good.
So I think if we were to write out 2m plus 5 squared out the long way, like 2m plus 5 times 2m plus 5, that would equal that whole thing right there.
What's that again? Oh yeah, if you expanded this out, you'd get back this and then this.
Sorry, yeah, I'm just like I'm a visual person, so I was trying to do it in my head and visualize it.
Like I say, going from here to here, I mean, going from here to here, from this to this is a process. You can just go through it. But going from here to here is pattern recognition. You can recognize this as square plus twice product plus square. Then from there to there just is the rule.
Okay.
And you could also do the AC method for this. We need two numbers P and Q whose sum is 20 and whose product is 4 times 25, which is 100. Sum is 20, product is 100. 10 and 10 work. So you could write this as 10m plus 10n and go through the whole AC method and wind up with the exact same thing as this.
Mm-hmm.
Doing it as a pattern recognition thing does save you a few steps, I think. Okay?
Okay, thank you.
Sure. All right, I think we're done for here. Let's see what we got. All right, stop recording.